Hi, my name's Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to talk about chemistry unit conversions. And there's basically two things that you can look at when you're doing unit conversions. You can talk about either the element or the compound. And it really comes down to kind of like knowing what a mole is. And we talked about that in the previous video, that a mole is just like the word dozen, where dozen means 12. Well, a mole is equivalent to 6.022 times 10 to the 23rd units. So it's a really big number, okay? Now, if we're talking about an element, that 6.022 times 10 to the 23rd units is talking about how many atoms there are in a mole, because the base unit for an element is an atom, okay? However, when we're talking about the compound, the base unit for a mole, okay, is going to be the molecule. So we're going to have 6.022 times 10 to the 23rd molecules for every mole if we're talking about a compound. I think this will make a lot more sense when we go into the examples. So let's get into the video, okay? Let's say I'm doing a problem where, or in a lab really, where I'm given 2.98 grams of aluminum. And I want to either figure out how many moles that is or how many atoms there are. Well, I would take that 2.98 grams of aluminum and I would set it up in my dimensional analysis, or what I like to call train tracks. And we're just going to basically do the same thing that we did when we converted kilometers to meters. We're going to do the same thing with grams to moles to atoms. Okay, so we have our given in the upper left-hand corner. We're going to bring it down so the units cancel out. And we're going to convert the grams of aluminum into moles of aluminum. So basically we're going from this box to this box. Now what you see in the red over here is going to be the conversion factor. So I need to be able to figure out the molar mass of aluminum. Now I'm just going to look at the periodic table that I have in my classroom, but if you have one in front of you, you're going to realize that the molar mass is 27 grams for every mole. Okay? And if you don't know how to calculate molar mass, please watch the previous video on molar mass. Okay, so I get out my calculator, I take 2.98, I divide it by 27, and as you can see, the grams of aluminum are going to cancel out, and I'm going to be left with moles of aluminum. And if I do this in my calculator, the answer that I get to 3 sig figs is going to be 0.110 moles of aluminum. Okay, well, what if I wanted to go a step further? Okay, what if I wanted to go past moles and I want to figure out actually how many atoms are in that 2.98 gram sample of aluminum, okay? All I would do is do the same process that I did here from grams to moles. I would do the same process for moles to atoms, okay? So I'm going to bring the moles down, and I do that so that they cancel out, and I'm going to be left with atoms of aluminum. So I went from grams to moles, and then moles to atoms. Grams to moles, and then moles to atoms. Now, when you convert from moles to atoms, the conversion factor is no longer molar mass, but what we call Avogadro's number, which is 6.022 times 10 to the 23rd. And that's how many units, okay, or atoms of aluminum are equivalent to 1 mole. Remember, the word mole is just like dozen. So in 1 mole, there would be like, or like in 1 dozen, there would be like 12 atoms, but this is 1 mole, so it's just a different number. And that different number is 6.022 times 10 to the 23rd. And I got to be able to punch that into my calculator the right way. Now, I know a lot of schools use this Texas Instrument calculator. Okay, so the way I would probably put this in, 2.98, okay, I'm going to divide by 27, and then I'm going to multiply by 6.022 times 10 to the 23rd. Okay, so hopefully this is close enough. So I'm going to hit multiply 6.022, and to get the exponential button, you're going to come up and hit the second button and the comma, and the big E will pop up. Okay, I'm going to take that out to the 23rd power. Okay, and when I enter that number, 2.98, divided by 27 times 6.022 times 10 to the 23rd to 3 sig figs, that's going to come out to be 6.65 times 10 to the 22nd atoms of aluminum. Okay, so we just, in this problem, we went from grams to moles, and then moles to atoms. So 2.98 grams of aluminum is equivalent to 0.110 moles of aluminum, and 6.65 times 10 to the 26 times 10 to the 22nd atoms of aluminum. Okay, and the next problem that we're going to do is we're going to work backwards. Okay, so instead of have the given of grams and work into atoms, we're going to start with the given of atoms and work backwards to grams, just to make sure that you guys understand how to do this forwards and backwards. So our next example, we are given 1.81 times 10 to the 19th atoms of carbon. Okay, so we're actually starting here in this box. Okay, and the question I want to be answered is how many moles is that? And how many grams is that? So let's go ahead and start our conversions. So just like last time, we're going to set up our train track, and whatever unit is here, we're bringing it down because we want it to cancel out. So we're going to have atoms of carbon down here, and we're going to take our atoms into the unit moles. And the conversion factor between atoms and moles is this Avogadro's number. Now remember, for every 1 mole, there's going to be 6.022 times 10 to the 23rd atoms. Okay, and if we stop the problem right here, the atoms would cancel out and we'd be left with moles of carbon. If I punch this into my calculator, I should get an answer of 3.01 times 10 to the negative 5th moles of carbon. Okay, so 1.81 times 10 to the 19th atoms, okay, is equivalent to 3.01 times 10 to the negative 5th moles of carbon. And if I want to take that a step further to figure out how many grams there were, I just repeat that same process. Okay, so bringing atoms down, I'm going to bring moles down. And I'm going to go from moles of carbon to grams of carbon. So moles of carbon to grams of carbon. And the conversion factor is molar mass. So I look at the periodic table and I figure out that there is 12 grams for every mole. Remember, the moles are going to cancel out. And if they cancel out, I'm going to be left with grams of carbon. And the answer comes out to be 3.61 times 10 to the negative 4 grams of carbon. Okay, so that's how you deal with an element. Okay, so and when I say an element, there's just one thing here. In this case, it was carbon. In the last example, it was aluminum. Okay, well, what if I wanted to go to a compound, something that consists of a lot of atoms just to make up one molecule? Well, if it takes a lot of atoms to make up one molecule, then there's an additional step into these problems. So if we start with grams, we can convert the grams to moles exactly the same way using molar mass. Okay. However, when we go from moles in a compound, the base unit is a molecule, where for the element, the base unit is the atom. Okay. In order to get to atom, there's going to be that one additional step. Okay. And we're going to use subscripts as our conversion factor to do that problem. Okay. So let's kind of get into one of those problems with a compound. So let's say my given is 100 grams of ammonium chloride. So 100 grams of ammonium chloride. As you can see, it takes up a lot of atoms. 1 atom of nitrogen and 4 atoms of hydrogen and 1 atom of chlorine. Okay, all those atoms to make up just 1 molecule of ammonium chloride. Okay, of course, those molecules can be converted to moles. Those moles can be converted into grams. Or in this case, we're starting with grams, and we want to figure out the total amount of atoms that are in 100 grams of ammonium chloride. So let's go ahead and do this step by step by step. So my given is 100 grams of ammonium chloride. And if I want to go from grams, the first step would be to moles. So I'm going to bring down the grams of ammonium chloride to moles of ammonium chloride, okay? And the conversion factor between grams and moles, okay, is going to be molar mass, just like it was last time, okay? So whenever you go from grams to moles, the conversion factor is going to be molar mass. Now, I need to do some calculating here to figure out the molar mass of ammonium chloride. So a lot of times I like to set up a little chart that has how many atoms there are. We got 1 atom of nitrogen, 4 atoms of hydrogen, and an atom of chlorine, and I'm going to multiply that by the atomic mass that's on the periodic table. So for nitrogen, it's 14, for hydrogen, it's 1, and for chlorine, it's 35.5. So 1 times 14 is 14, 4 times 1 is 4, and 1 times 35.5 is 35.5. If I add everything up, this comes out to be 53.5 grams for every 1 mole. This is the molar mass, and that's the conversion factor between grams and moles. It says 53.5 grams for every 1 mole. So 53.5 grams for every 1 mole. Okay, so that's how we convert grams to moles when it's a compound. It's a little bit more tedious because we got to add all the elements that make up the compound, whereas for the element, we just had to look at the periodic table and look up the atomic mass. Okay, so compounds, a little bit more challenging. Okay, so if I do the math here, 100 grams divided by 53.5, I get an answer of 1.87 moles of ammonium chloride. So these are equivalences, okay? For every 100 grams of ammonium chloride I have, that's the same thing as me saying I have 1.87 moles of ammonium chloride, okay? Well, if I wanted to go a step further and figure out how many molecules there are, because the base unit for a compound is going to be a molecule, I'm going to take these moles of ammonium chloride and convert it over into molecules. So this says MOL, this says MOLC, which stands for molecules of ammonium chloride. And what we know about the mole is it's just a number, just like the word dozen. For every 1 mole, you're going to have 6.022 times 10 to the 23rd units for that mole. Well, the unit for a compound is a molecule, where the unit for the element was an atom. So that's kind of like the part that you have to differentiate between elements and compounds. The base unit is going to be a molecule. So right now, the grams have canceled out, the moles have canceled out, and I'm left with the unit of molecules. So 100 divided by 53.5 multiplied by Avogadro's number, and be very careful of entering that in your calculator because a lot of people make mistakes right there, is going to come out to be 1.13 times 10 to the 24 molecules, MOLC, of ammonium chloride. So 100 grams is the same thing as 1.87 moles, which is the same thing as 1.13 times 10 to the 24th power molecules of ammonium chloride. And the last bit is to figure out, well, how many atoms would be present in that 100 grams of ammonium chloride. And we just continue our train track one more step, and we're going to go from molecules, MOLC, molecules of ammonium chloride, into what I'm going to call total atoms, okay? So I want to figure out how many atoms in total, are in this 100 grams of ammonium chloride. Well, here, to go from molecules to atoms, you have to use the subscripts, okay? And in a molecule of ammonium chloride, there's going to be 1 nitrogen, 4 hydrogen, and 1 chlorine. Just like we said before, 1 nitrogen, 4 hydrogens, and 1 chlorine. I'm using these subscripts, okay, to figure out how many atoms are in 1 molecule. So 1 nitrogen, 4 hydrogen, 1 chlorine, That's a total of 6 atoms for every 1 molecule of ammonium chloride. So I take my 100 grams, divide it by 53.5, multiply it by 6.022 times 10 to the 23rd. If I already have that in my calculator, just leave it and then hit multiply by 6. That's going to tell us how many atoms total are in the 100 grams of ammonium chloride. And that answer comes out to be 6.75 times 10 to the 24. So in 100 grams of ammonium chloride, there is 6.75 times 10 to the 24 total atoms. I hope that helped you be able to convert between some common chemistry units of grams, moles, molecules, and atoms. Okay, and if you found this helpful, please do a like, a subscribe, and even add a comment, because that comment really helps the YouTube algorithm and helps us share how to learn chemistry in a straightforward fashion.